today starts our lessons on polynomials. So we're going to start off with a bunch of vocabulary. So a polynomial looks something like this. We have a coefficient and then an x with an exponent, and then another coefficient, and our next exponent is going to be at least one lower than the previous one. And it'll keep on going on until we get down to just an x term and a constant term. So we will always like our polynomial functions to be written in standard form. And standard form for a polynomial is very similar to standard form of quadratics. The exponents go from greatest to least. When written in standard form, it'll be easiest to find the greatest exponent because it'll be first, but in general, the greatest exponent represents the degree of our polynomial. The term containing the highest exponent, because it's at the beginning when it's in standard form, is called the leading term. The coefficient of the leading term, which will be the number in front of the x with the highest exponent, is called the leading coefficient. And the term of degree 0, meaning that there is no x, is called the constant. So, constant is when there's a degree of 0, and this is going to be something like f of x equals 5. There's no x terms after the equal sign. If it's a degree of 1, you spent most of Algebra 1 learning about first degree polynomials. They're called linear because they make a line when you graph them. So this would be something like f of x equals 3x minus 7. Our second degree polynomials, we just spent the last couple months learning about. What's it called when we have an x squared in our function? Hopefully you remember, it's quadratic. Third degree means we have an x to the third power, which we learned about in our first unit of functions. These, hopefully you recall, are called cubics. And then a fourth degree polynomial is called a quartic, and it's going to look something like f of x equals negative 5x to the fourth minus 2x squared plus 4. The highest exponent is 4, and we could have an x cubed term or an x term in there if we wanted. This is just a random example. So let's put this vocabulary to use. Now, determine if the following are polynomials. In order to be a polynomial, the exponent must be positive and no x's in denominators of fractions. Sorry, the exponents have to be positive numbers. They cannot be variables, and no x's in denominators of fractions. So number 1, 8a to the 5th. The exponent is positive, so yes, this is a polynomial. Standard form, since we only have one term, it'll also be the first term. The leading term, 8a to the 5th. The degree would be 5. And the leading coefficient would be 8. Do you think number 2 is a polynomial? Hopefully you said it's not a polynomial, and that's because it has a negative exponent there. And number 3. Yes, this is a polynomial because it has a positive exponent. This one technically has an exponent of 1. Standard form, we want the highest exponent to come first. So 9x cubed plus 2x, which makes our leading term 9x cubed. The degree would be 3, and the leading coefficient would be 9. So let's rewind back to 4th grade when you learned long division. So if you recall, we take 19 and we see how many times 19 can go into 40. Hopefully you said that would be twice. What's 2 times 19? It's 38. So then we subtract. We get 2. Bring down the 8. Then we need to see how many times does 19 go into 28. That would just be once. Then we do 1 times 19, get 19. Subtract. You get 9. Bring down the 6. How many times does 19 go into 96? That would be 5. 5 times 19 is 95. Subtract and we get 1. So it's 215 and 1/19. We just put the remainder over our divisor. We're going to use the same process and idea to help us divide polynomials. So what we're going to look at is how many times does x go into x squared? Well, if we divided x squared by x, we would just have 1x left. So now we're going to multiply x times this whole thing. So x times x is x squared. X times 1 is x. Then we need to subtract. X squared minus x squared is gone. 3x minus x is 2x. And then bring down the plus 7. Now we divide 2x by x. That would give us plus 2. 2 times x is 2x. 2 times 1 is 2. Then we subtract. 2x minus 2x cancels out. 7 minus 2 is 5. That's our remainder. So our final answer is x plus 2 plus 5, and we put it over what we were dividing by, x plus 1. Now, there's a lot going on in here. We have variables of different exponents, and then we have a lot of coefficients. So what we can use is a process called synthetic division, which is actually basically just a shorthand version of long division. We're going to start off by taking the divisor, x plus 1, and setting it equal to 0 and solving it. We get that x equals -1. So that's going to be what we use as our divisor in synthetic division. And then we're going to make like an L shape. And we're going to have 2 lines of writing inside of here. And the numbers we're going to use to divide are going to be the coefficients of each term. So 1, 3, and 7. The first term in here is always going to drop straight down. Regardless of what it is, we're just going to bring it down. Then we take that term on the bottom and multiply it with the term on the side. So 1 times -1 is -1, and put it underneath the next term inside. Then we add these together. 3 plus -1 is 2. 2 times negative 1 is negative 2. Put it in the next column. Add down your column. We get 5. In this problem, our first thing is to do x squared divided by x. X squared divided by x equals just x, so that we know that this first number is the coefficient of our x term. So we have x plus, after our x term comes the constant term, and then your final thing is your remainder, so plus 5 over x plus 1. Now let's see how this relates to what we got here. We know we got the same answer. If you look in here, coefficient here, the 1 just came down, 3 and negative 1 were right here, 7 and negative 2 were right here. So let's see why we need to use synthetic division. So, an expression that divides exactly into another is called a factor. For example, we know that 9 is a factor of 36 because 36 is divisible by 9 with no remainder. Something that can help us, if x minus k is a factor, if we were to set that equal to 0 and solve it and plug k in to the equation, we would end up with 0 at the end. If x minus k is a factor, then x equals k would be a root or a solution to the equation. We could also say it was a 0 or an x-intercept. The important thing here, what we're going to use, if we're given a factor, a root, or a solution to an equation, we can use this with synthetic division to find other roots. So let's look at an example. Use synthetic division to determine if x plus 2 is a factor of this polynomial. So we're going to set up our synthetic division. We know our coefficients are going to go inside, so 3, negative 4, negative 28, and negative 16. The first thing we need to do is take x plus 2, set it to equal to 0. If we solve that, we know x equals negative 2, so negative 2 is what goes outside for our synthetic division. Take the first term, drop it down, we get 3. 3 times negative 2 is negative 6. Add our column, we get negative 10. Negative 10 times negative 2 is positive 20. Add down our column, we get negative 8. Negative 8 times negative 2 is 16. Add down our column, we get a remainder of 0. If something divides with a remainder of 0, we know it's a factor. So yes, x plus 2 is a factor. So now that we know that x plus 2 is a factor, we can use that to help us factor this whole thing. If we hadn't already done the synthetic division with the x plus 2 and 3x cubed plus or minus 4x squared minus 28x minus 16, we'd have to do the synthetic division first. But since we did it in this first part, we can just go ahead and write our new polynomial. We started with an x cubed and divided it by an x, which means the first term of our new polynomial has to start with x squared. So here we have 3x squared minus 10x minus 8. Since our first term started with squared, an exponent of 2, we know our next term has an exponent of 1, which means our last term doesn't have an x at all. So now we need to factor this. I'm going to factor by grouping. I know some of you liked factoring using the box method or trial and error better, and feel free to do that and check your answers with mine. So if we're going to factor by grouping, 3 times negative 8 is negative 24. And then what multiplies to negative 24 and adds up to negative 10? That would be negative 12 2. So we get 3x squared minus 12x plus 2x minus 8. Group our first two terms and our second two terms. These two have a 3x in common. So it'll be x minus 4 left over. Plus these two have a 2 in common. This will also have an x minus 4 left over. So our factors are 3x plus 2 and x minus 4. Since it asks us to completely factor, right now we only have an x times an x, and that's only x squared, and we started with an x cubed, so we need to include the factor that we were given. So that's our completely factored version. If we wanted to take it one step further, if we wanted to find the roots, we would start with synthetic division, then we would factor. Since we've already done that in the previous two examples, all we need to do is take those three things and set them equal to 0 to find our roots. So if we subtract 2, we have 3x equals negative 2. Divide by 3, we have x equals negative 2/3. Here we would add 4, so we get x equals 4. And here we subtract 2, so x equals negative 2. A good way of checking your work, you started with an x cubed, so you had 3 x's multiplied together, and we ended up with 3 answers. Now, a little bit of caution to be careful about. If a term is missing, and let me explain what that means. Here we went from cubed to squared to x to constant, which is good. That's our sequence. We went 3, 2, 1, 0 with our exponents. Say it went x cubed and then jumped down to x. We need to put in a 0 in our synthetic division as a placeholder for the missing term. So let me just add on a quick example. If we had f of x equals 3x cubed minus 28x minus 16. Regardless of what we're dividing by, when we set up our synthetic division, 3 is the coefficient for our x cubed. We don't have an x squared, so we're putting 0 x squareds in there, minus 28x minus 16. A nice way to check and make sure you have the right number of terms in your synthetic division is our exponent was 3, so we're going to have one more term than that. So it starts with we had a cube, add 1, you should have 4 terms inside. That's all for today.